We're surrounded by AI. It's in the chatbots that help write our emails, it's in the complex systems that are starting to drive our cars. But how they actually think? Well, that's often a complete mystery, a black box, even to the very people who build them.
So, what is actually going on inside that box? Come on, let's pry it open and get a good look at the real architecture of a machine's mind.
To really get how a non-physical intelligence can have a very, very real effect on our physical world, we first have to understand something fundamental, how it perceives reality itself. Yeah, this isn't like looking at normal software code where you can just read through the lines. An AI's knowledge isn't stored in some neat, orderly fashion. It's intuitive. It's learned from experience, and it's spread out across this massively complex web of artificial neurons. The answer is honestly fascinating. It lies in a concept that takes our entire world of words, of images, of ideas, and translates all of it into the pure, cold language of mathematics. I want you to imagine a giant, multidimensional library. But here, books aren't organized alphabetically. They're organized by their conceptual meaning. So, king is placed right near monarch, and walking is just a stone's throw away from running. An AI understands the relationships between all these ideas by simply measuring the distance and the direction between them in this incredible space. And what's really incredible, just mind-blowing, is that AI can perform a kind of algebra on these concepts. This famous example shows it all. By just manipulating these vectors, the AI isn't just matching words, it's actually reasoning about abstract relationships like gender and royalty. It's doing math with ideas. So, if AI thinks in these strange, high-dimensional mathematical spaces, how does it talk to itself? I mean, what does its internal monologue even sound like? Turns out it has a native tongue. It's called Neuralese. It's a way for the AI to completely bypass the slow, clumsy, and kind of lossy process of translating its incredibly complex thoughts into our human language, only to have to translate it back again. And this right here, this just illustrates the trade-off perfectly. For an AI to think in a way we can follow, it has to use what we call a chain of thought, basically talking itself through a problem in plain English. But when it uses its own language, Neuralese, it's literally thousands of times faster, more nuanced. But to us, it's completely opaque, unreadable. And that creates a really serious challenge, right? I mean, if we can't observe its thought process, how can we be sure it's not developing some kind of flawed logic or hidden biases? How do we trust a mind that speaks a language we literally can't understand? So, okay, we have this incredibly complex internal thought process, but how does that translate into actual action? How does a non-physical mind reach out and interact with and even manipulate our very physical systems? This is where we find the ghost in the machine. An LA or LLM empowered autonomous agent is the system that connects the AI's abstract vector-based thoughts to real, concrete actions in our world. And here it is. This is the crucial link. The AI uses these external tools as its hands and eyes. All the planning, the reasoning, that happens in the super-fast abstract world of Neuralese. But the execution? That happens through APIs that can connect it to pretty much everything, from financial markets to critical infrastructure like our power grids and communication networks. This is exactly how a non-corporeal intelligence can have a very, very real physical impact. So, given that incredible power, how do we make sure these things are reliable and safe? Since we can't read their minds, we have to become master detectives. We have to rigorously test their behavior, poking and prodding them from every angle we can think of to find the breaking points before they find us. And to do that, we basically use three main approaches. Black box testing treats the AI like a total mystery. We just poke at it from the outside like a normal user would. White box testing is the opposite. It gives us the keys to the kingdom with full access to all the code. But honestly, it's often this middle ground, gray box testing, that's the most revealing. It lets us see how these agents use their tools, giving us a vital window into their actions without getting totally lost in the mind-bending complexity of their internal logic. This whole challenge, this desire to have the power of AI without the risks of it being a black box, has given rise to a whole new and incredibly important field, explainable AI, or XAI. Now, the mission of XAI isn't to dumb down AI.
Not at all. It's to find clever new ways to build systems that are just as powerful, but whose decisions we can actually understand, question, and ultimately trust, especially when we're trusting them with our finances, our infrastructure, and our safety.
And all of this leaves us with a final, crucial question about the future we're all building together. As these powerful, non-corporeal intelligences become more and more integrated into our world, we really have to ask ourselves, what does it truly mean to be in control?